Gas laws. First of all, gas. Gas has no definite shape and no definite volume. This is due to the weak intermolecular forces which exist among the molecules of gas. And due to these weak intermolecular forces, gas molecules move far apart from each other to occupy the maximum available space. And gas has four variables. We can calculate these four variables for the gas: pressure, volume, temperature, and mass. Mass depends upon the number of moles. Pressure is measured in kilopascals or pascal, which is a SI unit of pressure. Volume measured in liters or milliliters, and temperature measured in Kelvin scale, and number of moles, which is represented by small n, is measured in moles or expressed in terms of moles. And the quantitative relationship between these four variables, pressure, volume, temperature, and number of moles, gives the gas laws. And there are four gas laws which are experimentally studied. First one is Boyle's law, then Charles' law, and third one is Gay-Lussac's law, and fourth one is Avogadro's law. Now we will discuss first law, that is Boyle's law. Boyle's law. According to Boyle's law, for a given mass of gas, given mass of gas means number of moles are fixed. The value of n is fixed if we have a given mass of gas, then number of moles are fixed. Next is at constant temperature. It means here temperature is also constant, its value is fixed. Pressure is inversely proportional to volume of the gas. P is inversely proportional to volume of the gas. This is the mathematical expression of Boyle's law, according to which pressure is inversely proportional to volume of the given mass of gas at constant temperature. Or we can write it as P is equal to K into 1 by V. Here K is the constant of proportionality. When we remove this sign of proportionality, we always put some constant, which is a K, which is here K. K is the constant of proportionality. And this is equation number 1. Or we can write it as PV is equal to K and name it as equation number 2. By taking the log of equation 1, this is equation 1, P is equal to K into 1 by V. By taking the log of this equation, we get log P is equal to log K minus log V, or log P is equal to minus log V plus log K. And this is equation number 3. It means we have here 3 equations of Boyle's law. First one, in which pressure is inversely proportional to volume, and second one in which the product of pressure and volume is equal to constant, and the third one in which the log of pressure is equal to minus log of V minus log of volume. It means when we increase the pressure, volume decreases. For example, if we take a container with a piston, and if these are the number of moles of gas, if we apply pressure over the piston, the volume of the gas decreases. The volume of the gas decreases if we increase the pressure over this piston. This shows that the pressure is inversely proportional to volume. If volume increases, it means pressure decreases. Graphical verification of Boyle's law. We also verify it through the graphs. First one is pressure versus 1 by V. If we plot a graph between pressure and 1 by V means volume, this first graph represents the pressure versus volume graph, which is a straight line graph. In this, we can write P is equal to K into 1, which is equation number 1. Here, Y is equal to mx. This is a straight line equation. And here y represents the y-axis and P is along the y-axis, and x represents the x-axis. It means if we compare these two, here 1 by V is along the x-axis and we left with K, which is equal to m. Here K is the slope of the graph, which is equal to K, m is equal to K, which is slope of the graph. And we can calculate slope of the graph by the formula tan theta, and this angle is theta, and from here we can calculate the value of tan theta, which is equal to perpendicular upon base. If we draw a line here parallel to pressure axis, which gives the perpendicular, and 1 by V in x-axis gives the base. From here we can calculate the value of tan theta, which is equal to m and which is further equal to K, which is the slope of the graph. In this way we can calculate the slope of the graph. Also, PV is equal to nRT, which is a ideal gas equation, and according to Boyle's law, PV is equal to K, which is the second equation, in which we have to plot a graph between PV versus pressure. Means the product of pressure and volume remains constant. Here it is Y is equal to mx. Y represents the PV and m represents the K, but there is no x, means the value of x is 0. That's why this line is parallel to x-axis or pressure axis because the value of PV is constant. And from here, if we compare these two equations, these PV are same, means left hand side are same, it means right hand side also are same, become same. Here N is the number of moles. For a given mass of gas, number of moles are fixed, it means its value is fixed, its value is constant. R represents the gas constant, it is always constant. And we left with only temperature, it means K is directly proportional to temperature. If we increase the temperature, the value of K also increases. And the third graph represents the decrease in volume with the increase in pressure. This third graph represents the decrease in volume when pressure is increased, and it varies exponentially with the volume. Pressure varies exponentially with the volume. And this fourth graph represents log P is equal to minus log V plus log K, the third equation. And this is y is equal to mx plus c. Here log P is along the y-axis, x here minus log V. Minus represents the decrease. Here this minus sign represents the decrease in the slope of the graph. That's why it decreases with the increase of log P. And this log K is C, which is a intercept. Intercept means which cuts the axis at one point. And the minus sign represents the decrease in volume. And from here, this log K, this is the intercept, or and M represents the slope of this graph, which is equal to minus 1 here. Here this minus sign represents the angle, which is equal to 135 degrees. The value of tan theta here is 135 degrees. This is tan theta. If we plot a graph at three different temperatures according to equation 1, P along the y-axis and 1 by V along the x-axis. Here we plot three graphs at three different temperatures, T1, T2, T3. And as we already discussed that the value of temperature is directly proportional to T. When the value of K increases, temperature also increases. It means T1 is less than T2, which is less than T3. And when the temperature kept constant, like in this, These type of graphs are called isotherms. These type of graphs are called isotherms. Significance of Boyle's law, and what is the importance of Boyle's law? At constant temperature for fixed mass of a gas, density is directly proportional to the pressure, and mathematically it can be expressed as d is equal to m by v, where m is the mass of the gas and v is the volume, d is the density of the gas. This is equation number 1. According to Boyle's law, PV is equal to K, which is a constant, or we can write it as V is equal to K upon P. And substituting the value of V in equation 1, we get D is equal to M by K by P, where M is the mass of given where m is the mass which is given, it means it is constant. K is always constant, which is a proportionality constant, and m by k represents the k dash, which gives the k dash. K dash is equal to m by k, which is a constant. From here we have d is equal to k dash into p. It means d is directly proportional to pressure. D is directly proportional to pressure. If pressure increases, density also increases. The question here is, why mountaineers carry oxygen cylinder with them at high altitudes? Because at high altitudes the atmospheric pressure is low. It means density of air is also low, which results in less oxygen available for breathing. It means oxygen level is also low. That's why mountaineers carry oxygen cylinder with them at high altitudes.